Hello, Cardinals. It's Mr. Mon, and you have just finished Investigation 5.1. So you are moving on to Investigation 5.2. Don't want to take too much time in between, but there are a few things you need to make sure you have in your notebook, and that's what this video is for. So the first thing I want you to do is, as you look back to Investigation 5.1, I want you to realize that you should have some kind of data table that looks something like this. Hopefully you did more than one trial for the stainless steel ball at different heights. And then most groups had a diameter of sand impressions, like a crater. And then you should have graphed it something like this. Your drop height should have been in centimeters, something like that. And then you have your drop height. And then the equation tells us that the higher the height is, the more potential and kinetic energy there is. So that is the increase in the crater. So you should have a data table that looks something like this and a graph that looks something like this. And then we do have one vocabulary word to add to page 49. It is kinetic energy, and it's the equation for that. Kinetic energy is impacted by both mass and speed or velocity. And the kinetic energy equation is a little bit more complicated than we've dealt with in the past. The equation is kinetic energy, which is measured in joules, equals 1/2 times the mass in kilograms times velocity squared, and that would be in meters per second. So it's half the mass times velocity squared. So kinetic energy is impacted by both mass and velocity. As you start Investigation 5.2, there are, I want to say, about 10 steps to get this done. The first one is to consider the equation when you're recording your calculations for gravitational potential energy. And now the question is, if two objects with different weights are dropped at the same height, which object will be associated with greater kinetic energy? You have the solid steel marble, and now you have the acrylic marble that you've used in the past. And here you're going to record your predictions in your science notebook. Step 2, you're going to read energy of motion. You should read this as a group. All right. So take a minute, stop the video or whatever you have to do, and read energy of motion. And that is in your textbook. And then step 3A and 3B, you're going to be talking about increasing an object's kinetic energy and then decreasing an object's kinetic energy. Step 4 is looking back at your predictions. And now that you have any information, do you want to make any revisions? Step 5 is you're going to be planning an investigation and using the two different sized marbles. You need to consider what variables you have, which ones should be kept constant, and which ones you change the independent. How does that affect the dependent variable? Step 6 is record your procedures. Step 7 is designing a data table. And step 8 is your teacher approval, and record your data in your table as you work. So step 8 is getting my approval and then working. Step 9 is discussing the information with your group. You need to plot this information and make a graph on student sheet 5.2. You tape that in as you came in today. And then finally, step 10, you're going to be writing a conclusion. This should be in a paragraph explaining how mass affects gravitational potential energy, and use data from your investigation to evaluate your predictions. So you have to use data from your investigation as evidence within there. So you're going to finish 5.1, which you should have already done. You've watched my video. Here are the 10 steps you need to get done. We're going to get as far as we can in class today. And then on Thursday, we will be finishing 5.2. Thanks, Cardinals. Good luck with your investigation.